So we are continuing on the particulate nature of matter, and today say on isotopes. So isotopes, they are coming from atoms, so we need to understand kuti chimbori chi, what causes an atom to become an isotope. And it so isotopes are atoms of the same element. They are atoms of the same element with the same number of protons but different number of neutrons. So when we say isotope, these are atoms of the same element. Ese ananga the same element. Let's say for example that chlorine, they say chlorine, chlorine, chlorine. But they have the same protons, which is the same number of electrons, but chakunonosiyana is they have a different number of neutrons. All together. So since they have the same number of same atomic number, they have the same atomic number, which means they are just the same what element, but then the different mass number is coming because anenge ane machi ma different number of neutrons. Remember patakambotaura about the atomic structure, we said kuti nucleus medu mune ma neutrons, mune machi protons. Anditi mune ma neutrons nema protons edu, chinoitika ndechekuti ma neutrons nema protons ese akatorwa together like this, we call them anonzi ma nucleons, like we said earlier on. Then these nucleons edu anotipa the mass of the what? The nucleus. And then this mass of the nucleus is regarded as the what? As the relative mass for the what? For the atom. And reason why it's a relative mass of the atom is because my electrons anengar kuno kundizo. These electrons are ane mass yechi 1 over what? 1840. So 1 over 1840, it's what we term to be a negligible mass. So since a negligible mass, we are only going to focus on what? On the insides, which are the nucleons. So their mass, the nucleons, is the number of protons plus number of neutrons. And it then up kana takuta sama isotope. Now we are now saying that this atom red rinoiranditika richabva raita another one rine same number of protons, rine 1 proton, but takuta different number of neutrons. At it. So let's say I angarma 1 1, I write pa mass 2. Then I ava 1 2 3, I got pa mass 3. So kusiyana kwatoita ma number of what neutrons kwakutoreva kutoti ma masses achona achaita sei achasiyana. So ma isotopes edu, they would have a different what mass, but what the same number of protons. For example, we have chlorine. Chlorine yedu in a chlorine 35 ni chlorine 37. Saka chlorine 35 yedu, it has 18 protons, 18 neutrons. Then chlorine 37, it has 20 neutrons. But both chlorine are just slightly different masses. Saka ndo zvatiri kuti ndo machi ma isotopes edu iwawa. And it. So let's look at an example. So this is how we find my chlorine edu like this. This is how we find them at a periodic table. And it. So waona chlorine iri pa periodic table yako yakadai anti. Saka 17 na 17 hour ndo the number of protons, which is the proton number. Ndio this one and this one. And also this 17 is equal to the electron number, which is the number of what? Electrons. Then after that 35 na 37 wedu ndo ama masses edu. And it ari ma masses edu kudai. So ndi yekutanga ndikati 35 minus 17, it gives me 18. So 18 is the number of what? Neutrons. Then yechi2 ndikati 37 minus 17 inondipa 20. Saka 20 is the number of what? Of neutrons. Saka the number of neutrons edu, it's 18 and 20. So they are different number of neutrons. But we see that they have the same number of protons. Then my masses edu, imwe ichatipa 35, then imwe inechi 37. They are different. So if we are to compare the isotopes, we would say that they have the same number of what? Electrons and the same number of what? Protons. Are we together? But achaita a different number of what? Neutrons as well as the different what? Mass. Saka takamatarisa kudai so ma isotopes edu ai takamatarisa, you'd find out kuti kuma electrons ma shells medu they are the same, and rine shell rine ne shell rine outermost iri, they are just merely the what? The same. And why are they merely the same? It's because they have the same number of electrons or the same number of protons, and it then chakunonosiyana mukati imwe yane 18 imwe yava nechi ne20 machi neutrons. Saka ipapa that difference will be the difference inotikonzeresa kuti tive nema differences in what? In masses. Then let's look at the application of it. So since ka simple topic ka diki we would want to look at the application such that kuti unoziya kuti ma questions pa anouya what are they really targeting, because in chemistry a lot of times unokwanisa kupiwa tuntu shoma shoma, wapiwa tuntu shoma shoma, then you find a lot of questions coming up from even just one sentence. And then question yokutanga evanzi, what is meant by the term isotopes? So you'd say that these are what? Atoms with the same proton numbers but different number of neutrons. So particularly you talk of the difference in the number of neutrons. And then question B, the other isotope X36, complete the table about this isotope. Saka pekutanga apa patatanzi one of the isotope X has a proton atomic number of 16, which is number of protons is 16, then a mass of 32, a mass of 32. So then tovatanzanzi another element, another isotope X36 complete about it. And saka isusu tataudzwa nzi nucleon mass yedu yekutanga is what? 32. Then tovataudzwa nzi nucleon mass yedu apa payavachi yava 36. So in other words, there was an addition of 4 neutrons. And it so in pama neutrons apa we're saying they are plus what? 4. And it then regaiti tarise ma neutrons ekutanga. And it ekutanga ma neutrons ayo we're going to say kuti protons inonzi mass minus protons, which is equal to 32 minus 16. So if we go 32 minus 16, we're going to have so that's 16. And it saka aita 16 kudaro, then isusu tovatanzi isusu the new isotope rine 36. And it so new isotope redu raita 36 kudaro, the number of protons edu we're expecting them to increase from 16 achiwedzerwa nechi ne4. And it awedzerwa ne4 anobva aita iwochi number of neutrons is what? 20. Then the number of protons remains the same. It's what? 16. Then the number of electrons remain the same. It's 16. Then the electronic structure remains the same. Why? Because the electronic structure is the arrangement of electrons, so it remains what? The same. Are we together? Saka tungoti 2, then tobata 8, then tikati 2 plus 8, it's what? 10 from 16, that's 6. So the electronic structure is what? 286. Kana tatodai, so we've completed our table. Then to enter the other one, number 2, study the table below. Saka table yedu E ndio tiri kustudy yedu ina P, Q, R and S, and it. Then we have the proton numbers, we have the neutron numbers, etc. And it runs which element has the greatest mass. So which element has the greatest mass? Saka kana tidaona element rine the greatest mass, let's say panapa tobva tangowedzera ka item kekuti what? Mass, and it. So we all know that mass yedu inenge iri equal to what? Neutrons plus what? Plus protons, and it. So takuti protons edu, that's 6 plus neutrons 6 panapa pekutanga papa, so the mass is what? 12. And then page 2, 12 plus 12, the mass is what? 24. Then the other one, 6 plus 8, the mass is that's 14. Then 2 plus 2, the mass is what? 4. So which element has the greatest mass? Explain your answer. The one that has the greatest mass is in a 12 in a 24, and it. Saka in a 24 yedu, that's what? That's Q. So Q. Then our explanation would be its mass is what? Then tovata edda is my additions edzata edda, it's what? 12 plus 12, which is equal to 24, and it, which is the what? The number of protons plus neutrons. Are we together? Then which of the two elements are isotopes? So isotopes, by definition, it's supposed to be, so that would be this definition would be our explanation, right? It's supposed to be having the what? Same number of protons but different neutrons. Are we together? Saka takwenda notsvaga ine the same number of what? Protons, but in a different number of what? Neutrons, and it. So if we can see P and R have the same number of what? Protons, but they have different number of neutrons. P edu in a 6, R edu in a 8. So what are P and what? And R. And one are the two elements which are isotopes. And the reason for the answer is primarily the definition of what an isotope is, and they have the same number of protons but different number of neutrons. Then to enter the next question, the element hydrogen has 3 isotopes. We have protium, deuterium, and tritium. Then the nucleon numbers of the isotopes are 1, 2, and 3. So when we say nucleon number, tukureva both number of protons and neutrons are added. So which means protium, it only contains protons. So it has 1 proton, then the neutrons are 0. Then deuterium in a 2, then the number of protons, they have to be the same. So 1 proton, then it would have 1 neutron. Then again, the number of protons remain the same because it's an isotope, SMR isotope, and then this one it would have what? 2 neutrons. So zvabva zvanzi complete the table to show the numbers of protons and neutrons in the 3 nuclei. Ndo zvatabva taita apa pana. Then B yachona yabva yanzi the melting point of D20 is 3.8 degrees Celsius, but of H2O is what? 0 degrees. Suggest the reason for this difference in terms of the attractive force. Are we together? In terms of the attractive force. Saka H2O yedu inenge ine 1 anditika. Then D2O yedu is deuterium. Are we together? Deuterium in 2 nucleon number yedu, it's what? 2 andit. Then H2O yedu would suggest that it would be a protium, and it saka, which means that the mass of what? Of this protium inenge iri diki, inenge iri 1, and it then here deuterium it's what? 2. Then zvanzi give suggest the reason for this difference in terms of the attractive forces. So in terms of the attractive forces, the difference yedu iripo iyo ndeyekuti iyo yanzi ine melting point yechi ye 3.8. It means it requires more heat energy to break the bonds, and then iyo yanzi ine uyu ine 0, it requires less what? Energy. So isusu for movement of molecules, for molecules to move, molecules ane mass yakakura anowanzoita tend to move less ndizvo zvere than ane mass inenge iri diki. So in terms of the attractive force, we would then have to talk about the attractive force kuti D2O ndizvo zvere has what? Stronger attractive forces than what? H2O. That's why H2O yedu in a lower what? Melting point than what? Than D2O. To enter on the 4th question, the diagrams below show the atomic structure of different particles. You have particle P, Q, and R. Then zvanzi name the term that describes the relationship between particle P and particle Q. Saka toda kutarisa pana P nachi na Q edu, and it. So if you can see panapa, they have 1, 2. Here we have 1, 2, 3 neutrons, and so in other words they have different number of what? Neutrons. But if you check my protons edu, panapa we have what? 1 and we have 2, and panapa we have 1 and we have 2. So it means that they have the same number of protons but different number of what? Of neutrons. So they are called what? Isotopes. And it then give one similarity and one difference between the particle P and particle Q in terms, and it and give one similarity and one difference. So we want the similarity 1. So similarity is that they have the same what? Number of protons, and the difference is that they have what? Different number of neutrons, and it or different what? Masses, and it. Are we together? and also this one the same number of what protons, or same number of what electrons, since electrons is equal to number of protons. And then we continue with the question, and then we look at B. State one similarity of the particles P, Q and R. Saka takuda similarity iri kuwanikwa kwese kuna P, Q na R. Are we together? Saka the similarity inenge iripo ndeyatoda kuona. Panapa tine 1 2, panapa tine 1 2, tine 1 2, and it. But if you can check, number of protons is supposed to be equal to the number of electrons, right? But panapa we have my protons it's 1 2 and 3, and it. But my electrons it's what 2, which suggests that somehow this thing is a what is an ion, because inenge ine ma different number of what protons nema electrons. Are we together? So kana yakadaro, the only thing that will say kuti chiri common kwese is valence what electrons. Saka it is the same number of electrons in outermost shell. Are we together? And ane the same number of electrons in the outermost shell, and that's basically the similarity among the 300. Then does particle R have similar relationship with particle P? R is an ion, P is an isotope, it's an atom. So we would say that they don't have the same relationship, and it. So they don't have, and it. And reason why they don't have is that P is an atom while R is an ion. That's why they are what? They are different, and it. And also the other thing is that mukatutarisa, they have different number of protons, so they can't be the same. And so that's it on what? That's it on the revision. Saka ndo zvinhu zvaunofana kuti ubate ukwanise kunzwisisa primarily on what? On my isotopes. So when you talk about isotope, tukutaura isusu kuti these are atoms of the same what? Element with different number of neutrons but the same number of protons.